Hello there. So today we are talking about this faded unit circle. Everyone's told you about it. You're like, what is this? We're going to figure out what the coordinates of points are on the unit circle. But before we start, I want you to pause this video and I want you to think about, could you fill in the angles in radians and degrees on that unit circle? So grab that handout I gave you and see if you can fill in all of those angles. Don't cheat. I'm about to move on. Pause it. Not kidding. Okay, so here is your unit circle. So all of these angles are, of course, already written in. It's kind of like that clock in my room. And so, again, if you think about these, you can go around and you can just do multiples of whatever and go around here. So I'm first going to start on the first quadrant of this, because if you want to memorize your unit circle, which I'm going to tell you how you don't have to memorize your unit circle, you only have to memorize the first quadrant. Okay, so we're going to start and kind of review those exact values that we did yesterday, and I'm going to start with this pi over 6 angle. Okay, and so we're going to start with pi over 6, and we want to find the trig values of pi over 6. And if I remember, or I converted, depending on how you feel about radians right now, I would know that this pi over 6 angle is equal to 30 degrees. And so if I went ahead and I dropped that altitude down, I would get this 30, 60, 90 right triangle. So if I remember those special right triangle business, across from the 30 is going to be 1, across from the 60 is going to be the root 3, the middle side, and then your hypotenuse is going to be 2. And so if I wanted to find exact values of this, if I wanted to find the sine of 30 degrees or pi over 6, that would be my opposite over my hypotenuse. And if I wanted to find my cosine of 30 degrees, that would be my adjacent over my hypotenuse. And if I wanted to find my tangent of 30 degrees, I would go ahead and take my opposite over my adjacent, which, remember, I don't have to rationalize that denominator down. Okay, but in case you didn't notice, this is called the unit circle, and the word unit is going to imply that this circle has a radius of 1. So what that means is all of these rays that are drawn out here with angles, they all have a radius of 1. And so I can figure out my ratios this way, but it doesn't really make sense if this whole triangle in here has that hypotenuse that equals to 1. And so what I could do, though, I could make my hypotenuse equal to 1 over here. If I divided each of these pieces by 2, and I had this new triangle that now has a hypotenuse of 1, still 30 degrees, opposite of 1/2, and then adjacent of root 3 over 2, you're going to notice that those ratios fall over here. So one thing to remember is that the unit circle has a radius of 1, or a hypotenuse of 1. Okay, but if I look here, I got the same values. So what that means is that that sine value, that 1/2, those two go together, that's my y coordinate. That's my y distance. So I went up 1/2 in order to get there. Okay, this adjacent, or my cosine value, I went over root 3 over 2. And so if I just looked at that and I could figure out already that on my unit circle, the y coordinate of any point is equal to the sine of that triangle, okay, and the x coordinate is equal to the cosine of that angle, that's going to help me name all those points. So I'm going to go ahead and erase some of this, and I'm going to write this as an ordered pair like you used to see in like 8th grade. And so when I have that, I know that my x value is going to be the cosine of that angle, so root 3 over 2, and then my sine is going to be my y value. And so now I know the coordinates that go with that angle of pi over 6 or 30 degrees. Okay, let's go ahead and do that other one. Well, there's 2 more, but whatever. Okay, so we're going to do pi over 4. And so, again, pi over 4, you can either convert or remember that that is equal to 45 degrees. So I have a 45, 45, 90 right triangle, and that means that the legs are 1, 1, and root 2. So you could go ahead and divide everything by root 2 to make it into this unit circle, but if we remember that whatever I get for my sine value, that's going to be my y coordinate. Whatever I get for my cosine, that'll be my x. So if I find the sine of this, that's going to be opposite over hypotenuse, 1 over root 2. Could rationalize if I wanted, don't really want to. Cosine of pi over 4. going to be the same thing, adjacent though, over hypotenuse, which happens to be the same here. So then that means that my coordinates on that point are 1 over root 2, 1 over root 2. Okay? And let's go ahead and do, I know I ran out of space. I have to extend my page. We're going to do pi over 3 now. Okay, and so pi over 3, remember, is going to be equivalent to 60 degrees. So it's again a 30, 60, 90, but now we have opposite the 60s, root 3, 1, 2. I'm going to go ahead and find my y-coordinate, which is going to be opposite over hypotenuse. And then I'm going to find my x-coordinate, which is going to be adjacent over hypotenuse. So I know that this other point is going to be 1/2, comma, root 3 over 2. So I just found all the coordinates of that first thing. And again, all I did was technically drop an altitude down and then play the regular special right triangles game. Okay, now the one thing that we didn't figure out with these coordinates is where's tangent fitting in? And I'm just going to tell you right now that tangent, when you think about it, is going to be your opposite over your adjacent. So if tangent is equal to opposite over adjacent, which we know in my triangle on this whole unit circle is going to be equal to the y value of the point over the x value of the point. Well, funny enough, we just said that the y value is equal to the sine value and the x value is equal to the cosine value. So if you want to figure out what the tangent of theta is, you have two options. You can take your sine over your cosine, or you can just take your y-coordinate over your x-coordinate, and that's how you can figure out your tangent. Okay, and again, you could also figure out all your reciprocal values knowing these two, because you just flip-flop them around when you're dealing with secant and cosecant and cotangent. Okay, kind of remember tangent is the rise over run business, y over x, sine over cosine. But now I know you're wondering, all we filled out was that first quadrant. So how are we going to fill out the rest of the quadrants? Well, we could draw our triangles for all of those other values and figure all that out, but we know the only thing that's actually changing here is going to be the sine of my x or y coordinate, because if I figured out the reference angle for 2 pi over 3, oh, I used the wrong color. If I figured out that reference angle, I would know that that reference angle is also pi over 3. So it should have the same actual values for the sine and cosine. It's just the only thing that's changed is that going to the left is going to make my x value negative. So if I want to think about this, everything that has the same denominator, so anything with that 3 underneath it, is going to have the same numbers in here. The only thing that changes is the sign. And you can kind of think about this as when you did the quadrants, when you were first learning how to plot points, and you went ahead and you were like, well, if I was over in quadrant 2, that made my x negative and my y positive. Okay, and that makes sense because my adjacent was the one that was negative, so my cosine would be negative. Okay, if I went down here to the other pi over 3 reference angles, I would have, again, the same values. But if I think about this, my adjacent's negative, and so my opposite's also negative because I went down. Okay, over here, same values. But now my adjacent's positive. I'm going back to the right side, but my opposite is negative. So my y would be negative. Okay, so that's how it's going to work for all of these. So for anything with the denominator of over 4, so 45-degree reference angle is all going to have this same value, except for here the x is negative. Down here in quadrant 3, both of them are going to be negative. And over here in the quadrant 4, my y will be negative. And last but not least, we have my pi over 6 reference angle. So this is going to have the same value, but different signs. Okay, x is negative, both are negative. And this guy is only y negative. Oh, did I write the wrong one? No, I didn't. I'm good. I got a little bit ahead of myself. Okay, so there's an easy way to remember this also, to remember the signs of your different quadrants. And this is an acronym that I learned as all students take calculus. So what that means is in the first quadrant, everything is positive. Sine is positive, cosine's positive, tangent's positive. Any of your trig functions are positive. In your second quadrant, the only thing that's positive is sine. So you can look here, only my y would be positive. And if I did my tangent and I found my y divided by my x, positive divided by negative is still going to get me a negative. So only sine is positive in the second quadrant. Down here in the third quadrant, only tangent's positive. And down here in the fourth quadrant, only cosine's positive. And that's true for their reciprocals as well. So that would mean down here, secant would also be positive, cotangent would be positive, or cosecant would be positive. So if you remember that, then all you really have to know is the first quadrant of your values, and then you can just remember, oh, my x has got to be negative, or oh, my y has got to be negative. Okay? Now, the only thing that we have not covered are these angles that are on your axes. And those are called quadrant border angles, or quadrantal angles, or border angles, or there's so many names for them, okay? Just basically those things that make your axes. So I went ahead and I just took away all of the other stuff, and what I want to remember here is first of all the angles that these are. So I know in degrees, this is 0, 90, 180, 270. It's pretty straightforward. We remember how that goes. Okay, in radians, this is 0 radians. This will be pi over 2 radians. This will be pi radians, and this will be 3 pi over 2. And because we know that this is a unit circle, every single one of these radii are 1. So if I look at this point and I named it using an x and y, I would know that this x was 1, and then I went up 0, so the y was 0. Okay, then up here, this would be 0, 1. This is still ones and zeros, it's just now it's negative because I went to the left. And down here, because I went down, it's going to be a negative 1. So if I remember that my cosine value goes with my x value, it would be pretty straightforward for me to go, okay, well, if I wanted to find the cosine of pi over 2, I simply look at the point 0, 1, and I pick the x value of it. So I would pick 0. And I would know that the cosine of pi over 2 is 0. Because it'd be really hard for me to try to draw a triangle on something that was straight up and down. Okay, and so if I remember that sine goes with y, it would be really straightforward for me to find something like the sine of pi, because that would just be me going over, finding that coordinate, so negative 1, 0, picking the y coordinate, and that would also be 0. Okay, tangent is a little bit more tricky because remember that sine over cosine, or y over x. So if I went ahead and I found the tangent of 3 pi over 2, remember here, I'm going to need to find y over x. So my y value down here at 0, negative 1 is negative 1 over 0. This is not good. We cannot divide by 0. So we say that the tangent of 3 pi over 2 is undefined, or u, or the whole thing undefined, or u and d, however you feel comfortable writing that. But if you see something divided by 0, we automatically stop. Okay? Now that was one way to remember it. I also have like a little acronym mnemonic device that's really, really helpful for this, and it goes like this. It goes O, I, O, I, O, U. Oh, I don't, O, I don't, O, you. So you're saying over here like, oh, I owe you money. Oh, wait, no, I don't owe you any money. So O, I owe you. Oh, I don't owe you. So the don't is the negative. And what this does is if you write SOHCAHTOA out, it's SOHCAHTOA. And then these down here on the horizontal are going to be angle measures. So this is 0, this is 90 or pi over 2, this is 180 or pi, and this is 270 or 3 pi over 2, whichever measurements you're in. So now I know, using this chart, if I wanted to go and find, for instance, the sine of pi, I would just go sine pi is 0. Okay, the tangent of 3 pi over 2 is undefined. So that's how this chart works. It works exactly the same. It's just a little less math involved. Okay, and the only thing that would be a little different for either of these things is if you wanted to go find, for instance, the cosecant of pi over 2, you notice that it only has SOHCAHTOA on the top. So you have to remember here that cosecant goes with sine. So I would go look on the sine column. And I'm going to go look at the pi over 2, which is 1. And the one thing that I'm going to remember about all of these values is if I'm trying to write this value, I'm going to have something over 1. Okay, I can always write a whole number as over 1. So what the sign of pi over 2 would be 1 over 1, or just 1. So if I take that and I flip-flop it, I get the same thing, and I get that it's 1. Okay, kind of silly that you have to do that, but if you try to take something like the cotangent of 0 degrees, and I looked right here, and remember cotangent goes with tangent, so this would be 0 over 1. So if I took 0 over 1 and I flip-flop that, I would get 1 over 0, I would get the bad news bears, and I would have to say that the cotangent of 0 is undefined. So basically, if you're looking at this chart and you're thinking about the reciprocal values, anything that was a 0 is going to be undefined, and if you flip-flop an undefined, it's just going to be 0. Okay, that's just going to be how it works. So you can either think about it using the x and y coordinates, or you can use your OIO chart. Okay, that's all I've got. This is a completed unit circle, and you can probably Google and find the same image in case you missed anything on here. Remember, you do not have to memorize the unit circle. I didn't ever memorize the unit circle, and I made it just fine through calculus. If you do want to memorize, I would take it one step at a time and remember quadrant 1 and all of those coordinates, and then I would go around and then maybe remember all students take calculus or etc. Also, something to notice here, they did rationalize the denominator. Remember, I don't have to rationalize. Hope you all have a great night.